This lesson deals with Supplemental Problem 8.2. You can find this problem in the course ebook in the Chapter 8 Supplemental Problems starting on page 2. Most op-amps are limited to a plus or minus 20 volt power supply because of the ratings of the transistors inside the integrated circuit. A thing called a bridge amplifier can roughly double the maximum voltage across the load by a clever use of signs. Let's find the voltage across a speaker with two different kinds of amplifiers. The first one is just an inverting amplifier with two resistors and an input voltage. Suppose that input voltage is 1.4 times the sine of omega t. The voltage here at the speaker is going to be minus the resistor ratio, which would be 10k divided by 1k with a minus sign times 1.4 sine omega t. So the output would be equal to 10 times the input, so it would be minus 14 times the sine of omega t. Now to drive a speaker, it's a relatively low resistance, and we need a special kind of an op-amp that can deliver the current. This is called a power op-amp. We're going to look at building one of these in the lab. Now the second circuit uses the first circuit, but now hooks up an inverting amplifier with a gain of minus 1. Here's the second power amplifier. The gain from here to here is just going to be equal to minus 10k over 10k, or just equal to minus 1. The voltage here is minus 14 times the sine of omega t. Then the voltage over here is going to be that answer times minus 1, or a plus 14 times the sine of omega t. And this is shown on the next page. So here's our first circuit result, with the voltage across the speaker being a minus 10 times the input, so minus 14 times the sine of omega t. And the second circuit, Vout2, was multiplying that result by a minus 1, so plus 14 times the sine of omega t. And I'm going to solve for the voltage across the speaker in the bridge amplifier. I'll let you look at the previous page. We have Vout1 on the left side of the speaker, and we have Vout2 on the right side of the speaker. Let's go around that loop. So the rise in voltage is Vout1, and the drop, as I've shown it on the previous page, is the speaker voltage plus Vout2. So we can solve for the speaker voltage as Vout1 minus Vout2. Let's see what happens. We've got minus 14 times the sine of omega t for Vout1, and then we get a minus a plus 14 times the sine of omega t. Total is minus 28. On our first amplifier, just the inverting amplifier by itself, the most we could get out was 14 volts peak. Now we have 28 volts peak. With a 15 volt supply, it's hard to get the full 15 volts out, and that's why I stopped at 14 volts. There's a little bit of distortion as you go between 14 and 15. Now both op-amps are still operating in their non-clipping regions. Now since power to a load is V squared over R, then if the voltage is doubled, then the power is multiplied by a factor of 4 from that of a single op-amp. All this power is coming from the power supplies or the batteries themselves. And this is Supplemental Problem 8.2.